Okay, students, now we are going to do some very important questions. These questions are selected after careful observation of the recent exam questions. Okay, and topics we are going to cover is atomic structure, periodic table, chemical bonding, S block, and stoichiometry. Most important chapter, and your chemistry start with stoichiometry. Okay. So all questions will be discussed in detail and with short tricks wherever if it is there. So try to make a proper notes of it. People are able to answer the chapter wise questions, but they are not able to take when 3 to 4 chapters are there. So to test yourself in that ability, this DPP is provided. Okay. So let's hope it will boost your confidence and definitely going to increase your score in your exams. Okay, here is the first question. Assume that nucleus of F atom. F atom means here fluorine atom. Of a sphere of radius is given, and we have to find out density. Okay, density you have to find out simple. Everybody knows that density is equal to mass by volume. Okay, and mass is equal to mass of every atom. Okay, mass of every atom or anything will be, see, density. Okay, mass of the fluorine is how much? 18. Atomic weight of the fluorine is 18. Okay, 18 divided by Avogadro number. Sorry, this should be 18. Okay, 18 divided by Avogadro number. This is the mass of each fluorine atom. Okay, 18 actually it is a mass number for 1 mole, but we want for 1 atom. Therefore, 18 upon Na. Okay, this is the mass. And volume will be 4 by 3 pi r cube. Volume will be 4 by 3 pi r cube. 4 by 3 into pi will be 22 by 7 into r. Radius is given as 5 into 10 to the power of minus 13. Gram per centimeter cube only we require. So this you can cube it. Understood? So then you will get density. Mass you are substituting here. Volume you are substituting here. Then you will get the correct answer. Okay. I think 6.02 into 10 to the power of 13. Okay. You can try. As per me, it should be the 6.02 to 10 to the power of 13. You might be getting that answer also. Okay. So there may be some calculation mistake, but procedure will be same. Okay. Now let's see the next question. 112 ml of gas produced by action of 41.2 mg milligrams of ROH with alcohol. Alcohol with the molecular mass of the alcohol is C. It is the organic and inorganic physical. Both are combined together. This is the Grignard reagent RMGI. Okay. In place of R, they have taken as a methyl. In place of R, what they have taken? They have taken as a methyl. So CH3 MgI. Okay. So when they both react with each other, simply this OH will be here and CH3 will be here. Okay. So sorry, CH3 and ORMgX. Okay. O on oxygen it will be attached. Okay. Product will be like this CH4 plus MgOHX. Okay. This magnesium is positive, it will go on to the negative. Methane gas is produced. Okay. So molecular mass of alcohol we have to find out. Understood? So this is if it is a balanced reaction. It is what? Balanced reaction. And balanced reaction is giving you 112 ml. Okay. 112 ml means you can compare it with 22,400 ml. Okay, will be the molecular mass. Unitary method, what you will write? 112 ml. Mass is 441.2 into 10 to the power of minus 3. Okay, then 22,400 ml gives how much? Okay, on calculation we are getting 8.24. Okay, what is the 82.4? Sorry. Okay, 82.4. I think it is print mistake. It should be 82.4. Okay. Okay, you can cross check once it is 82.4 or 8.24, but process is same. Okay. Now let's see the next questions. Okay, next question. A compound contains 3.2 percentage of oxygen. Minimum weight of the compound is. These model questions so many times it is repeated. Here minimum molecular weight means minimum one oxygen must be there. Okay. So 3.2 grams of oxygen, okay, is 100 molecular weight. Okay. Then minimum oxygen mass is the 32. Okay, minimum oxygen mass will be how much? If 1 mole is must, okay. So 16 grams of oxygen is equal to how much? Okay. So answer will be something like this: 16 divided by 3.2 into 100. So 1600 divided by 3.2. Okay. So how much we should get? I think it is 500. Okay. It should be 500. Okay. 500. That means fourth option is correct. You can check with the calculation. Actually, I am making this only just for giving you the concept of solving. Okay. Then number of oxalic acid molecules in 100 ml of 0.02 normal oxalic acid. Okay, normality is given. You have to find out number of moles. First of all, simply directly what you can do, you can put it in the normality formula. Normality is equal to number of equivalent moles divided by volume. Okay, so number of equivalent moles will be volume into normality divided by 1000, because it is volume is in milliliter. So uh, volume is 100, okay, into 0.02 divided by 1000. So it will be 0.002. Okay, these are equivalent moles, not moles. Okay, so then obviously what will be the moles? Moles will be just half of it. Okay, moles will be 0.001. Okay, 0.001 means into Avogadro number. Into Avogadro number. So 10 to the power of minus 3. So 6.023 into 10 to the power of minus, 20. Okay, so answer will be first option. This is the correct answer. 54th first option, 53 fourth option. Okay. Okay, next question. 100 grams of a sample of mixture of calcium chloride and sodium chloride. Okay, so 10 grams. Whenever this type of value is there, then you have to find out calcium chloride CaCl2. Okay, so out of this 10 gram, you will take calcium chloride as a x gram. Then sodium chloride will be 10 minus x grams. Sodium chloride will be how much? 10 minus x gram. When treated with Na2CO3, produces a calcium as a calcium carbonate, heated to convert calcium oxide. This is called as a sequential reaction. Understood? So initially what it is there? CaCl2. When it is treated with Na2CO3, then it is converted to CaCO3 on heating CaO. Okay. So from this we can say if 56 grams are there, okay, 56 is the molecular mass, then it will be triple one. Then it will be how much? Triple one. So 1.62 grams are there, then how much mass is there? Very simple. Okay. So I am solving here. 56 grams is equal to triple one grams. What is triple one? Molecular mass. And 1.62 grams is equal to how much? 1.62 divided by 56 into triple one. Okay. I think it is 2 jar, 3 jar. 56 3 jar. Try once. Okay. So this is simplification you can do. and on simplification you will get the mass. Okay, so that mass divided by 10 into 100 will give you the actual answer. Actual answer will be like that. Okay, so answer we should get 32.1. Calculation you can do it. Okay, answer only I am telling you. Then 56th question, it is simply KO2 is used in oxygen cylinder in space submarines because, okay, because very simple, it absorbs CO2 and increases here potassium superoxide will produce the oxygen. Both purpose will be solved. It also gives the oxygen required in submarines and also absorb the CO2 available. Okay. Okay. Next question is among KO2 AlO2 minus, okay, AlO2 minus BaO2 NO2 plus unpaired electron is present in, unpaired electron is present in. Okay, it should be, what should be the answer? It should be KO2 only. Okay, because all are peroxides and there is one unpaired, but because of positive charge it will be removed. Okay, next, which of the following do not decompose? Do not decompose on heating. This was clearly told to you in the S block lecture. Okay, actually Li to CO3 is also not supposed to be, but because of what, in a anomalous behavior it will decompose. Okay, BaCO3 also correct. So Na2CO3 does not decompose. Okay, next, these are all discussed in detail in the S block. Okay, if you get time, try to go through that S block lecture. I will give you the link in the description box. Okay, the solubility of water in sulfates. How to remember this solubility? This tricks also explained. S block main problem is that series increasing order, decreasing order, like that. So many questions are there. So how to remember them logically? Okay, how to remember them logically? It was clearly explained. So you can go through that. Okay, answer for this will be solubility of water in sulfonates down the beryllium group is, okay, it is due to actually simple coordination number is high. Okay, that you can cross check afterwards. Now let's see the next one. Okay, LiNO3 on heating, LiNO3 on heating gives NO2, which will emit the NO2, which will emit the N2, which will emit the NO. That already list is there. Heating effect. There is a lecture called as a heating effect. So you can go through that. Okay, answer will be O2 and NO2. Okay, O2 and NO2. Understood? Then solutions of sodium metal in liquid ammonia reducing due to presence of solvated electrons. Okay, the solvated electrons will act as a reducing agent. Okay, then the compounds insoluble in acetic acid. Okay, insoluble in acetic acid is simple, it is acid and this is also acid, so rest all are basic. Okay, rest all are what, basic, that's why it is insoluble. Okay. Okay, next, when dissolved in dilute H2SO4, when dissolved in dilute H2SO4, 0.275 grams of metal evolved these many ml of H2 at hydrogen collected over the water. So this pressure will be minus of this, okay? 780.4 minus 1.74 will be pressure of the hydrogen, okay? And metal evolved, okay? So then equivalent weight of the metal. Simple, any metal plus H2SO4, okay, will give MSO4 plus H2. Okay. So depending on the volume of hydrogen, you can calculate moles of metal. Okay. So that many moles is the these many grams. Okay. Then 1 mole you can calculate. Understood? So first of all, PV is equal to nRT. So number of moles will be PV upon RT. So pressure will be 780.4. This you will write it in the pressure, and volume is in milliliters. So zero point 0 you can convert into liter. Divide by 1000, it will be in liter. R value will be 0.0821, and temperature will be already given 20. So 273 plus 20. Okay, so 293 is the temperature. Now you will get moles. So from this moles you can find out the molecular mass. Okay, see whatever you get, that will be of the equivalent mass. Okay, I think it is clear to you now. Any doubt? Answer you will get on simplification 27.52. What will be the answer? 27.52. Okay. Find weight of KOH in its milli equivalent. Milli equivalent will be direct formula. Okay. Mass upon equivalent mass into 1000. Okay. So mass is given, milli equivalent is given 50. Okay. Mass we want to find out. KOH mass will be 39, 40, 40 plus 16, 56 into 1000. Okay. So then you will get milli equivalent. Mass is equal to, okay. So answer will be, you will be getting almost to find the weight of KOH. Okay. So answer will be 2.80. That is true. Like this you will get. Okay. Next, number of neutron in a drops of water. Here, this is the main problem, is that neutrons they are asking, and in 1 ml, 1 ml is equal to 20 drops. Okay. So that means what is the volume? 1 by 20 ml. Okay. At 4 degrees Celsius. At 4 degrees Celsius. At 4 degrees Celsius, actually it will be density is equal to 1. Maximum density of water found at 4 degrees Celsius, and it is equal to 1. Okay. So this ml can be converted into grams. So mass is equal to 1 by 20 grams. Okay. Mass is we are given, and you must be knowing 18 grams will contain, 18 grams will contain only 8 neutrons, 8 neutron into Avogadro number. Hydrogen does not have any neutron, so don't multiply it with the 10. Okay, then 1 by 20 contains how much? So when you divide with 1 by 20, you will get it answer as 6.023 into 10 to the power of 23. Oh, sorry. On simplifying, 1.338. 1.338 into 10 to the power of 22 we will get. Okay. This is the process. I think it is clear where the students have mistaken and why you should not mistake. Okay. Then maximum amount of Ba3PO4. Actually here maximum amount means you should know the limiting reagent. Okay. So I will write the reaction. BaCl2 plus Na3PO4 will give you NaCl plus Ba3PO4 whole twice. Okay. So here for balancing purpose I am telling you what I will take here 3 moles, here 2 moles. Then it will be 6 NaCl. Okay. 6 NaCl, 3 already Ba3PO4. So this will be the answer. Now here 3 mole require 2 mole. 3 mole require 2 mole. So zero point 0.5 mole require 0.5 divided by 3 into 2. Okay. So what will be the moles? 0.5 divided by 3 into 2. So this will be 1. Okay. 0.5 into 2, 1 by 3 moles. 0.33 moles required, but we have only 0.2 moles. So this is the limiting reagent. So according to this, 2 moles if we are using 1 mole Ba3PO4, but we use zero point 0.2 moles. So answer will be 0.1. Okay. What will be the answer? 0.1 will be the answer. Okay, 0.1. Fourth answer is correct. Then equal volumes of KMNO4, K2SO4 used to oxidize acidic medium. Then amount of Fe oxidized will be equal volumes of 1 molarity each. Okay. See, actually here its equivalent factor is 5. Here its equivalent factor is 6. So then there will be different amount of oxidation. Okay, so why? Because equivalent factor is different. What is for different equivalent factor? 1 mole it will lose 6 electron, and 1 mole it will lose how many electrons? 5 electrons. So this amount of Fe oxidized will be more with K2Cr2O7 because it is giving more electrons. Okay. Okay, very simple. It is just like a mathematic quadratic equation or equation making only. P2Q3 PQ2 molecules. If zero point 0.1 moles of P weighs 15 point, okay. So here P2 suppose 2 into P plus 3 into Q, okay, into 0.15 is equal to, okay, moles upon molecular mass. You will get the mass. Okay, actually see, mass divided by molecular mass is equal to moles. So mass is equal to moles into molecular mass. These are the moles and this is the molecular mass. So how much we will get? 15.9 it is given. But here P plus 2Q, P plus 2Q into 0.15 is equal to how much? 9.3. Two equations are there, and simplify, you will get the P and Q atomic weights. Okay. So simple equation, but let us solve it, and answer you will get 21 and 26 and 18. What you will get? 26 and 18. Okay. Then 26 and 18. Next, 4 grams of impure sample of CaCl3 produces 0.88 grams. Very simple. Values are so easy that calculation will be automatically easy. So 2 moles we have to take CaCl2 plus H2. H2O plus CO2. Okay. So here we take 100 grams if we use, we will get 44 grams. So 0.88 grams how much? Okay. So 0.88 divided by 44 into 100. So this will be zero point 0.2 I think. Okay. So zero point 0.2 into 20. Point answer will be 20. Okay. So zero point 0.2 grams, sorry. 0.2 grams, I think. Okay. 0.02. This will be 2 grams. Okay. 0.0 to 2 grams. That means 50%. Out of 4 grams, only 2 grams of calcium carbonate is there. Therefore, 50%. Okay. Is it clear? This will be very helpful for advanced examination also. Okay. So don't forget to revise through this before advanced exam. Okay. Next, calculate weight of the iron produced, FeO produced from 2 grams of BO, and here equation is already given. Okay. Main thing you have to remember, actually this is dramatic situation. In actual examination, you will be given with the atomic mass. Okay. So report the at only you have to find out the limiting reagent. Okay. For that you will be given in the examination, you will be given. Okay. So VO atomic mass actually 67, and Fe2O3 at least you can find out. Iron is well known element. Fe2O3 this will be 160. Okay. So here you can write 67 gram require 160 grams of Fe2O3. Then 2 gram require how much? Okay. So 2 divided by 67 into 160. Okay. Then you will find out whether it is less or more. You will find out, then you can identify both are limiting reagent, one is limiting reagent. Answer should be, according to me, 5.18 grams are I am getting. Okay. So but we have 5.75. So this is extra. So this is extra means limiting reagent will be VO. Okay. 5.18. Okay. Calculate the, okay. Just a minute. Okay, actually here balancing is the problem. I thought that the equation is already balanced, but here 2 into 67 require 3 into 160. Okay, then you have to find out like this. So 2 by 2 into 67, 3 into 160. So this and this will get cancelled. Here answer will be more than 5.75. Okay, requirement will be more than 5.75. Therefore, Fe2O3 will be limiting reagent. Fe2O3 will be limiting reagent. Okay, next, how many grams of NaOH will be needed to prepare 0.01? Very easy question. Molarity is equal to mass upon molar mass divided by volume. So zero point 0.1 mass we have to find out divided by 40, 250 into 1000. Okay, 254 ja, so mass will be zero point 0.1 into 40 divided by 4. 4 and 4 will get cancelled. 1 gram, I think. Okay. 1 gram. Answer will be 1 gram. Here answer is 1 gram. Okay. Then 280 ml of H2O2 react completely with 158. Then volume strength of H2O2. See, this milli equivalent and this milli equivalent will be same. Okay, in acidic medium. So 115.8 divided by molecular mass. Okay, molecular mass of KMNO4, if you find out, it is 158. Okay, 158 divided by 5. This is the milli equivalent. Okay, milli equivalent must be 280 into normality. Okay, so then you will get normality. Normality direct formula you can find out with the volume strength. There is a trick given in the Chem. Okay, trick to find out normality into molarity into volume strength into mass percentage. All three conversion factors are given. Okay, you can go through that. Now let us see the next one. Okay, zero point 0.1 gram of sample of Fe2O3 solid of 55.2 purity. That means 55.2 grams only out of this 1 gram. Okay, out of this gram, 55.2 divided by 100. That means 0.552 grams only you have to take. Okay, reduced by heating with zinc dust. Okay, so Fe2O3 reaction I am writing here, Fe2O3 plus zinc. So zinc will be oxidized and iron will be reduced. Okay, so zinc oxidized and iron will be reduced. Okay, for balancing 3 zinc and 3 zinc oxide. Then resultant solution. Resultant solution is cooled and made up to 100 ml. Okay. Then aliquot of 50 to 25 ml requires 0.17 ml of oxidant for titration. So here then you will multiply. You will multiply this. You will get the milli equivalent. Okay. Or millimoles. Okay, and for neutral titration, calculate number of electron taken up by the oxidant. Taken up by the oxidant means n factor only we require. What we require? N factor. Okay, we require the n factor is what we require. 17 into 0.0167 into n factor. So once you find out the n factor according to this equation, 6. Actually here it is. This is a previous question, only value changed here, K to Cr2O7. So equivalent factor will be 6. Okay. So let's see the next question. Alkali metal sulfate have formula. Okay. M, very simple. Alkali metal. Alkali metal will be what? Sodium sulfate. So X value will be how much? 2. X value will be 2, like Na2SO4. So here alkali metal, if the question is alkaline earth metal, then X value will be 1. Okay. Alkaline earth metals directly combine with sulfur to form phosphorus, and sulfur and phosphorus heated to form sulfide. Oh shit, very easy. Okay. MS, alkaline earth metal, and type of phosphide will be M3P2. Okay, so answer will be 3. Is it understood? So here x is equal to 3, here x is equal to 2.